times is free.
Okay.
So that's $1.38. But that's for only 12, and there's 7 12s and 84.
Okay, so then
I multiplied by 7.
Okay,
And it's
okay.
$9.60.
So this was your 4 quarters?
Yeah.
So that then was times 7?
Yeah.
Okay. And then now I'm just checking your
2
work against mine
dimes.
doing the long way. And so then 2 dimes times 7. Okay. And then what do you have?
3 nickels.
Our first question.
So 3 nickels times 7.
And 3 pennies.
And doesn't success feel good? Yes. That's brain research, by the way. Your brain just rewarded you. It created something called, it's opiates. Literally, the brain creates opiates to reward you for success. That's why it feels so good. First question is, were there any surprises? Did anything come out of this that you did not expect? Yeah. Thank you. So the connections that you found were not immediately obvious in the task to other content. So I would call that a surprise. Thank you. What else? Yes?
I immediately thought that there would be a pattern, more so than there was.
It wasn't immediately visible pattern is what you're saying. It wasn't what you expected. Yeah. Did anyone have difficulty even... Yes?
What method did you guys use when you didn't see the pattern you expected? Did you use a picture or manipulative? Some of us use manipulative, some use pictures. Because we saw such a clear pattern by laying it out with manipulative. So
I think what she's saying, though, it wasn't the obvious what she thought she would say.
okay, right.
Yes. Yeah. Wasn't the obvious.
But what I'm hearing over here is another point. That some strategies lent themselves more quickly to discovering the pattern than others. Was there a commonality of those strategies? What strategies seemed to emerge first with the pattern and you felt really, really good about it? Maybe you can't answer that yet.
We decided to go with 12 instead of laying out 84 because 12 is a multiple of 2, 3, and 4.
And they blamed Edna for that, by the way.
Right. And then we went with 24. We said, let's really look at this pattern. Yeah.
Okay. Why 12?
It's a multiple of 2, 3, and 4.
Okay.
The second quarter, you replace with a dime, and the third, you replace, and the fourth, you replace. So 12 is a multiple of all of those.
How many students will see that? Initially. Okay.
That's what, because that's how it starts.
We've used this task with teachers, and some of them don't start with enough blocks. And they go, there is no pattern. They're sure there's no pattern. And we're walking around saying, now what? So the question was, what if you use more blocks? Because we want to keep students moving ahead through questioning, not by telling them what to do. Is it likely that the pattern of 12 is a result of the task and not an initial discovery? Is it possible? And what content does that then allow you to discuss with the students? Why is it 12? Do you think they'll come up with a good answer? I think they will. Because they had their hands on it, and they thought about it, and they looked at it. How many of you tried just pencil and paper? Our experience is that it is not as easy to see the pattern as it is with pattern blocks. Because the pattern blocks shout at you in color that your pencil and paper does not. Now, if you use colored markers, that might be better. The idea is the mathematics comes from the task. We did not teach you first the common multiples for 2, 3, and 4, or any other. What would be foundational knowledge, though? When they have to know something about multiplication, to see a pattern, and to eventually get where you want it. So you place this task where they have the foundational knowledge, but you haven't taught first what the task is to uncover. Does that make sense? We call that the spirit of Common Core. Will students persevere and make sense of this problem? Moderately engaging, don't you think? And in fact, knowing the pattern is not the answer. Angela.
I think the most interesting thing about the problem for me was the question. That I became much more intrigued by the questions I was having than the answer. I didn't care what the answer was. But I really got interested in questions.
Good. Good. Other comments about using tasks, this task? Yes?
I just have a question. Because I've been kind of trying to work with it and see, and we've destroyed our pattern.
Teacher voice.
Sorry. I've been trying to look at this and see, and we kind of destroyed our pattern, so I can't see it. But right off the bat, I figured out that pennies would make up a 4. And I'm just asking because I haven't had time to work through it. Can you find the answer algebraically, or do you have to find a pattern?
We had some others try that strategy in the room, so I'm going to turn it back to the room.
It was very complicated to develop.
Can be done, but very complicated is what I hear. Okay.
It's not so bad up to the nickels. It's that the pennies don't come uniformly out of the nickel signs and quarters.
Possibly proportionally, but not uniformly. Is that a fair statement, Isaac?
A different number of each of the 3 coins is taken to form the pennies.
And that complicates it.
Yeah.
Will you have some students who go that direction? Absolutely. And is that valuable thinking? Absolutely. Yeah.
And you can generalize the question. You could ask different questions. Change some of the criteria. And one question might be, how many different values can you get depending on how you alter, for instance, where you start the alternating?
Nice extensions.
I was just going to say, one of the things that we haven't talked about yet, we will eventually, is a good task. You may have some students finish it very quickly, and you could give them then the extensions. You could change the problem a little bit to keep them working. Now, Steve jumped right to the general. I mean, you have to know your students. Eventually, that's where you'd like to take them, if you could. And will everybody get there? No, they won't. But the idea is to differentiate for our brighter students without just saying, here's more problems of the same type to do. It's the same problem, we just changed the question or the situation. And hopefully eventually get them, if there is a generalized case, get them to that point. So that's kind of the other thing about good tasks. You can change the question a little bit to make it more challenging and continue to do that to keep students working on tasks. It was interesting. I was walking around and somebody was using their computer and drawing quarters on their computer and was going to do it electronically. Isn't that interesting?